So I'm going to try and make the gallium disappearing spoon, in which I take liquid gallium and I'm going to make a spoon mold. But I thought it would also be fun because I had this little bear, make a little bear mold. I had this little bear mold. So that's my gallium. So cool. Normally at room temperature, gallium is a solid, but I'm in a warm room and this is warm enough to keep my gallium in the liquid state. And gallium liquefies. And question is, can I touch it? Well, absolutely. And if you've been following my videos, you've seen I've shared quite a bit of gallium videos. I love gallium. It's my favorite chemical element. But look at that. Beautiful, beautiful gallium. So that will wipe right off. But I try and save as much as I can. Okay, so let me do the experiment. So I'm going to take some of my gallium and put it into this spoon mold, filling it all up. Look at that. I think I'll have just enough. And gallium melts around 30 degrees Celsius, so it doesn't take much to turn gallium back into a solid. It should solidify at room temperature, but I'm going to speed up the process by putting it in my freezer. So here's my ice tray. I'm just going to put the two molds into the ice tray and then take it over to my freezer. That probably less than 5 minutes, and I'll have frozen samples of my bear and my spoon. Okay, just to speed up the solidifying process, I'm going to drop the temperature down by putting this into the freezer. Just give that a few minutes, probably 5 minutes. And then I'm also going to heat up some water. You'll see why in a second. So this is going to be the warm water for the second part of the experiment. A little messy. Very hot, but we're going to let this cool down to where I can actually touch it, so like bath water temperature. First, let's look at the spoon. Let's see how the spoon did. So this is my gallium spoon. It's so tiny. I know people have made larger spoons, but I don't have that much gallium. We're going to take it out of the mold. Oh, look at that. Beautiful spoon. And the question is, if I hit it on the side of a glass. So yeah, definitely, I think I had success making a little tiny gallium spoon. But what I like to show is a trick that they say you can pull on your chemistry professor, but maybe not because your chemistry professor knows chemistry. But what if you gave your chemistry professor a nice warm cup of tea and you set the spoon next to that cup of tea and you said, okay, here, enjoy your tea, but make sure you mix it before you drink it. So you take the spoon and you mix that spoon in the tea. And that's why it's called the disappearing spoon experiment. Because this being, like I mentioned, I let it go to like near bath water, okay? I just melted my gallium spoon, but I didn't lose it. Let me show you why. I'm going to pour the water off. Oh, you can also see how gallium, of course, because it's a metal, it has a higher density than water. And so it's going to sit down at the bottom of water, which is nice. And it's a metal and it has an attraction for itself. So even if I did separate it, try to put it in 2 pieces, it's going to attract itself again to its other piece. So I'm not losing my gallium. Okay, I'm going to pour off as much of the water as I can. But this next part is really cool. So check this out. If I put it on the paper towel, the paper towel doesn't absorb it. The paper towel just absorbs the water because that gallium metal is a large metal. Those are large atoms for gallium. And so the water it is a liquid, but a paper towel will not absorb this liquid metal. I think that's really cool to see that. But yeah, so I'm just moving it around the paper towel, and you can see there's no evidence of wetness on this spot. So I can be pretty confident I've gotten rid of all of the water that was in contact with my gallium. And it doesn't dissolve in water, just got wet, just like if you got a bar of metal wet. It would be the same as if I got these crucible tongs wet. So, you know, if I took the crucible tongs and I put them into the water and then I set it on the paper towel, of course, I know it's a solid, but it is still a metal. So I can dry this off just like I can dry off the gallium. To recover my gallium, this is my little gallium tray. And I like to work with plastic when it comes to my liquid gallium. It doesn't have as much of an attraction as when I work with glass, because I still have traces on this glass of my gallium. And I can usually wipe them off. Look at that. Watch what happens when I put the gallium on the table. This is pretty cool. So if I take my liquid gallium and I let it, and you notice how every time it rolls, it gets shinier? That's because it is solidifying temperature in the room. So on the outside, it is solidifying. So it does solidify, but then as I roll it, you can see it gets more liquid. You can see it more liquidy because I will start to get chunks right there. But I can cut this in half and then just roll it back together. And then not only that, if I get really messy with my gallium all over the table, like I said, it's a metal and it has an attraction for itself. So I can take this and roll these back together and collect all of my gallium, or most of it. What you're seeing here on the table would be the same thing as if I had iron and my iron filings were kind of shaved off. So I still have some gallium here, but what I usually do is I take a wet paper towel and you can see how it wipes right off. And yeah, that is gallium right there. So I try not to lose too much of my gallium by letting it smear on the table. But I'd like to show that demonstration just to give you an understanding of how I can collect my gallium. Now I have to scoop this up. My technique is to take the scoopula and a little wooden spatula, and I can usually get most of my gallium right there. That was a good cleanup. I do try to be mindful to the metals I'm working with. This is stainless steel. If this was aluminum, I wouldn't use it because gallium does have an interaction with aluminum. It's not, it looks like a dangerous interaction, but it's not really dangerous. I posted a video about that previously, but it's pretty cool to see that interaction. But yeah, so I recovered my gallium and it's a recycle process. So the big reveal, did I make a bear? Did I make a gallium bear? So I'm gonna take it out of the mold and let's just pop them right out here. Look at that. Look at that cute little bear. Yeah, it's a bear. So it's a solid piece of gallium. You can even hear it clinging on the side of the glass. And like the disappearing spoon, let's see if we can do the disappearing bear. I'm gonna use tongs to hold this. Not that my water's too hot, it's actually like bath water. all the gallium is falling to the bottom of the water, but it's not interacting with the water. Gallium in water, it's just like any other metal. It's just getting wet with the water. Pour off some of the water. You can see. So let's recover the gallium. I'm gonna pour it off and watch this. This is what I really like. So I need to dry off this piece of metal, and even though it's in the liquid state, I can still use a paper towel to dry it off. All out. Okay, so you can see there's still water on it, but I could pat off that water. See how it gets absorbed by the paper towel? But the only thing absorbing on the paper towel is just the water, because watch. See that? And if I roll this gallium, okay, if I roll this gallium over to a dry piece of paper towel, I'm not losing my gallium. Push it all off. There. That's how I dry off my gallium. And then I'll transfer it to that. Look at that. And beautiful gallium.